everybody, welcome back to my channel. I hope that you are well. If you're new here, then hello, my name is Beth. I'm a maths graduate from the University of Southampton, and today I'm going to be telling you 3 things that you should know before you start your maths degree. Number 1, know your Greek alphabet. The Greek alphabet is something that is obviously used all the time in mathematics. More often than not, we're using alphas and betas, not A's and B's. And while I wouldn't necessarily recommend sitting down and learning all, I think, 24 Greek characters, I would recommend at least just being familiar with them, so that A, you can actually refer to some of them by name, you're not just calling everything squiggle, and B, you can actually write them down when you're writing your own notes, and both of these things are going to make it so much easier when you're communicating, whether that be like in an exam form or just asking your peers or your lecturers any kind of problem that you're stuck on. If you can actually name the character you're talking about, it's going to make it a lot easier. The second thing that I recommend that you really brush up on before you start your first year is your integration and your differentiation. It may seem obvious and it may seem like something that you're already very comfortable with, which is great, but despite the fact that you spent most of the last 2 years of A-level doing just integration and differentiation, the sun is suddenly really bright. It's something that at university level you are just expected to be able to do relatively easily and relatively quickly. At least for me on my course, a lot of first year was really heavily reliant on calculus. So being able to integrate and differentiate, knowing that sine goes to cos goes to minus sine, being comfortable with the product rule, the quotient rule, the chain rule. Quite often at A-level, that's something that you can break down into a lot of steps, or it might be worth quite a lot of points in an exam situation, whereas when you get to degree level it's something that you do need to just be comfortable doing. Quite often universities will give you some kind of summer prep work or recap sheet to do between finishing your A-levels and starting your university course, because they don't want you to forget anything that you've learned over the last 2 years. They want to keep your brain active. I know that's something that definitely happens to me. If I don't do maths for a while, it takes quite a long time for my brain to readjust to it and to sort of brush away all those cobwebs. So if you have been given work like that by your new university, then I definitely recommend doing it, because not only is it going to be really helpful to keep your brain ticking over, but also anything that they're expecting you to be relatively comfortable with going into your degree is going to be on that sheet, so it gives you a kind of hint about what you should already be knowing. If you haven't been given any work by your university but you want to sort of brush up on some things and prepare yourself a bit more, then maybe go through a past paper. I'd say go through a pure paper focusing mainly on integration, differentiation questions, maybe a little bit of algebra, laws of logs, laws of indices. Just practice those core skills that you're going to be using come September, and I think you'll be good to go. The third thing that I think you should know before you step into that lecture theatre on that first day is some of the notation we use. Some of it you may already be familiar with, which is great, but some of it you may not be. So just in case, here are the ones I think you should know just to start you off. First of all, implies. Now you've probably already seen this one before, you've probably used it at A-level, but similarly at A-level you've probably used the therefore sign, the 3 little dots in a triangle. Usually at A-level, if you wanted to conclude an argument, you would put 3 little dots to mean therefore, and then you'd write your final statement. But that notation isn't really used at all at degree level or higher. It's just not. We prefer to use the imply sign, the arrow sign, I think because it's a bit more universal, and we can also flip the direction that way as well. So that's one adjustment to try and get used to. Every time you want to go and put that therefore sign, use an imply sign on an arrow instead. Following on from that, we have if and only if. It's a double implication sign, so the implication goes both ways. Sometimes we just write this as if, as in IFF, to mean if and only if. So if we have a statement that says if A then B, and we have a statement that says if B then A, we could write that as A if and only if B, meaning that A and B can only apply at the same time. Some more symbols you might need to know. This little box, sometimes filled in, sometimes not, and usually in the right hand margin of a page means end of proof. This upside down A means all or for all. This backwards E means there exists, and this little e symbol means is an element of. So you may have seen this in A-level maths. For example, X is a real number, X is in R, and that little symbol means that X is an element of or a member of the set of real numbers. And I suppose following on from that, you should know the set of real numbers, the set of integers, the set of natural numbers, the set of rational numbers, and the set of complex numbers. So the notation used for those and what it actually means to be a complex number, a natural number, etc. Which you probably already do know, but just in case you don't. So those are my 3 picks for what you should know before you start your maths degree, and obviously there is so much more that is going to come up, but the reason that you're going to be going to university in the first place is to learn. So loads more symbols are going to come up throughout your first year, but as you're introduced to them, they'll get explained to you. I've made a notation guide which basically summarises everything that I went over in this video, but it's in one like PDF, so it's nice and easy to read. You can print it off if you want to, you can refer back to it when you're reading your notes. So I'll leave a link to that in the description if you'd like it, if you'd find it useful. Thank you all so much for watching, I hope you found this video helpful, and I will see you very soon.